Hi, how you going? Now in today's video I'm going to be looking at the example of a roller coaster. In a roller coaster, obviously the first hill has to be the highest, and the reason that's the case is because it's going to use potential energy and convert that potential energy into kinetic energy. So at point A it's going to have only potential energy. At point B over here we'll have potential energy plus kinetic energy as well. So obviously we need to know those two formulas. So the first thing I'm going to do is calculate the potential energy at point A. So all I need to know is the height above the ground. So we know that the potential energy is equal to mgh. So that's equal to the mass. Now if I say this was equal to 100 kilograms, gravity, for this particular case we'll use 10, and then the height is 90. Right, so in this particular case over here, that's going to be 90,000 joules, or we might say that is 90 kilojoules. So that's the energy that we have at the start of the roller coaster. Now what's going to happen is at point B, that's going to be converted to kinetic energy and also potential energy. Now the height at B is in fact 70 meters. Alright, so at B, the height is equal to 70 meters. That's really important because what we could do, and there is several ways you can do this, you could simply work out the potential energy at B. We could call that potential energy A. That would be again mgh, which would be 100 times by 10 times by 70. So that is equal to 70,000 joules, which would be equal to 70 kilojoules. Right, so we know that obviously it's started with 90 kilojoules and it's now got 70 kilojoules. Then we know that the kinetic energy that it's going to have at B has to account for the difference in the energy it's lost. So therefore kinetic energy is equal to 20 kilojoules. Right? Now we also know that kinetic energy is equal to a half mv squared. So the first thing I want to do is I want to rearrange that equation to work out what the velocity is. Alright, so the first thing I'm going to do here is go velocity squared. Now I'm going to bring the 2 up to the top line, so it's going to be 2 lots of kinetic energy at B, and I'm going to bring the mass down to the bottom line. So that's going to give me my v squared, and so v is going to be equal to the square root of all that. 2 times kinetic energy of B over the mass. 2 lots of, now I've got to put that back into joules, that's 20,000 joules all over 100, because that's what the mass is. So that's going to be equal to, now if I work out that, so cross 2 zeros off, so it's going to be the square root of 400, and that would work out to be 20. Alright, so that would be 20 meters per second, would be the velocity of the roller coaster at that particular place. Now, I'm just going to show you another way of doing this, and I did this in class, but we'll do this again. Now, the two formulas that obviously you need to know are the potential energy and the kinetic energy. Alright, so if we know the potential energy at the top equals the kinetic energy at any particular point. Now we know potential energy is mgh, and we know that kinetic energy is half mv squared. Now the mass is not going to change. We can rearrange this, and I'm going to say that 2gh, so the half goes up to the top, is equal to v squared. So therefore if I wanted to say this, therefore V is equal to the square root of 2GH. Now that's really important because what this formula can do for you, it can allow you to work out the velocity of the roller coaster at any height based on the fact that it's changed its height. So it needs to be compared to the change in the height. So in this case, if we're looking at point B, if we were trying to work out the velocity, then the velocity would be equal to simply gravity, which we're saying is 2 lots of 20, 2 lots of 10, which is 20, and then you times that by the height. Now the change in the height in this particular case is in fact 20. So therefore that will give you the square root of 400, which works out to be 20. So it gives me my answer. So with that formula, it allows you to work out the height or the velocity at any height along the roller coaster without having to work out its kinetic energy. Alright, so in this particular case you could actually use the velocity formula here, and then once you've got the velocity you can put that back into the kinetic energy formula and work that out. Right, so the case that we've looked at is for a roller coaster. Obviously we can look at lots of other different examples when we start looking at kinetic energy and potential energy. Alright, and I'll show you one of those in our next video.